Hello guys, welcome to the video, and today we're going to be going over the, sorry just one second, repeated string problem. It is a easy problem with a 90% pass rate. So the prompt goes, there is a string S of lowercase English letters that is repeated infinitely many times. Given an integer n, find and print the number of letter A's in the first n letters of the infinite string. The example they give us is S is equal to ABCAC and n is equal to 10. The substring we consider is ABCACABCAC, which is exactly 2 times the that is exactly 2 of our string. So they basically just merge 2 together. The first 10 characters of the infinite string. There are 4 occurrences of A's in that substring. Okay, so pretty simple problem so far. They want us... Okay, so... the first thing that I would like to do is probably just go ahead and print out the input. But honestly, I think that this one should be able to get knocked out in just a matter of a few minutes. So let's print out the input data. This is kind of unnecessary because I think that I already know the solution. We'll see. Okay, so cool. And then because I'm programming in TypeScript, I know I'm a weirdo. I need to return a number, and let's go ahead and just initialize a count variable while we're here. Return count. Beautiful. Okay, so we're rocking. So I'm just going to run this and make sure we understand the input fully, make sure it's exactly as we would expect. And yeah, everything seems pretty normal. So here's what I'm thinking. There is definitely a way to look at like the length of our string, or whatever length of the substring it wants us to take, and then look at our original data, and instead of actually concocting a string that's like, or concating a string that, you know, could be very long, and concating strings is a pretty, if I remember correctly, it's a pretty costly operation. We should be able to do something with either the modulo operator or some other operator to get an idea of how many A's there would be. Because like if you look at this, it's saying that, you know, n is equal to 10 and the string's length is 5. So if you double the string, then, you know, if you take the amount of A's that's in the string and then you multiply that by 2, you basically get the answer. Let me think though. I'm kind of curious about the situation where n is less than the length of the string. Okay, so I think what I'm seeing here is whenever it gives us a string and a number of letters, or like it gives us the substring, the length of the substring it wants us to take, we literally just count the amount of A's that we find up until we reach the end of the word. So like, for example, it gives us a substring of length, well, it gives us a string of length 5 and then a substring of length 10. So we would basically count the first 5 letters of the substring, the entire length of the substring, in this case because the length it wants us to take is greater than the length of the actual string itself. But like if you were to get, you know, a substring of length 5 and they want you to take 2, then in our case, A, B, C, A, C, you would just count A and B, and then you would know, okay, one letter A appears in that string. And then another thing is if, like, for example, you know, N did not perfectly divide S, or S did not perfectly divide into N, like say, you know, our string is length 5 and the substring is length 12, then you would take a modulo operator and you would say, okay, I want the full length of the string. So we know that in the full length there is exactly 2 A's. But then I also, since, you know, 12 modulo 5 is 2, I also want the first 2 letters of the substring. And so you would simply count from that point on. Seems pretty good to me, so I think we're going to work from here. And since this is simple, I'm just going to go ahead and program this all in one shot. So what we're going to say is we are going to say, okay. That should definitely not be 90. Okay. So pole divisions should be the floor of n divided by s dot length. And what this is going to do is this is going to say, okay, if we have a string of length 5 and they want us to have a substring of length 10, then we know that, 5 divides into 10 twice, right? And if it was uneven, say, n was 12, then the floor helps us to say, okay, it evenly divides 2 times, but then we have a partial length down here, and that partial length will be equal to the modulo. So that would be n mod s dot length, I believe. And this should work pretty good. And then because I don't want to have any mistakes with the inputs, we're just going to go ahead and console log this. Gosh, I suck at typing. Beautiful, beautiful, beautiful. All right. So I'm going to run this and we'll see how this does. Okay, so it gives us, as an input, it gives us ABA and a length of 10. So that would be times 3, that is 6, plus 1, it's 7. Oh, yeah, expect output 7. I should have just looked at that. So in all, this divides 3 times and has a partial length of 1. That's perfect because 3 times 3 is 9, plus 1, perfect. That did exactly what we wanted it to do. So now what we are going to say, okay, let me ponder this over. Basically what I'm looking at here, what I'm confused about, is how we're going to manage the flow, because I want to do this in one for loop. So I want to go in one for loop, I want to find both how many A's is in the partial length. So for example, if we're going back to our example of a string length of 5 and n of 12, the partial length would be 2. And I would like to find how many A's is in the first 2 characters here. And in that same for loop or while loop or some sort of loop that iterates over the string, I would also like to know how many letters are in the entire string. And I would like to do that without any redundancy. So just looking at this, I think what I'm going to do is just go with a normal for loop. I'm going to say if I is less than or equal to, not probably equal, I is less than s dot length. And that's only if I can break out of this. So I know that there's not always going to be a case where I want to go to the end of s, so I'm going to try to add some logic to handle that situation. So all right. I'm going to initialize an A count. If string of I is equal to the letter A. Count plus plus, and then if I don't know if I do actually need 2 counters here. I don't think I need 2 A counts. I'm actually going to go ahead and remove this. I'm just going to go back to count. So we're going to say if we see an A, we're going to count it. And then if I probably need to run an actual different check up here. I want to make sure this only runs. And see, this is really making me think I need a for loop. If I is greater than partial length or no, it's not an or, it's an and. Whole divisions is less than 1. Okay, that should work. We're going to break out of this if that is the case. Otherwise, we should be able to just count this, I believe. So I'm just going to go ahead and run this. And my thinking here is that we're going to iterate once over the string, and we're going to record all the A's within a partial length. And if we surpass the partial length, like if we read, beyond the point that the string, the partial point of the string, we need to make sure at that point that there's multiple whole divisions. Because, for example, the string divides into n twice. Well, in the example of 12, it divides into n twice. So we need to definitely consider the full amount of letters. No. Yes. Oh boy. Okay. So that we would run into scaling issues if we do it the way I'm suggesting. What we really need to do is we need to keep account of two different measurements: the whole like the amount of A's in the entire string and the amount of A's in the partial string. So let whole count number 0. Let Is there? I'm gonna ask ChatGPT. I wonder if there's an easy way to count letters in JS. Probably regex patterns, honestly. I'm gonna move this little ChatGPT window over here so you guys can see it. Yeah, okay, so you can, in fact. Okay. Alright. Okay. You know what? I want to test my knowledge of regex patterns, so I'm going to just go ahead and redo some of this. So we don't actually need a for loop. I think that that's actually... Okay, so the whole count is going to be s.match, and isn't it forward? I could have sworn it was forward. Nope, that's a comment, so must not be. That doesn't look right either. Regex? Oh, that's definitely what it's supposed to be. Yep, definitely. No, it's forward. Why is it being like this? They're forward. Okay, so that's why. So I'm gonna match. I suck at this. I need to go back and do more regex patterns. Okay, cool. So we got the whole count and now the partial count. So for the partial count, I'm probably going to go with string.splice, and this is kind of an expensive operation, and I wouldn't advise for this if you were like really getting serious about this. Slice. And that is because resizing and rebuilding arrays is somewhat costly, and that's kind of what we're doing here. So we're going to slice from the 0th element to the partial length element, and then we're going to say dot match, say a, and then we're going to say dot length. Okay, cool. Count plus equals whole count. Oh, not what I meant to type. That's funny. Whole divisions, whole count times whole divisions. There we go. Beautiful. Count plus equal. You know, I could do all that in one line. Okay, partial count. Nope, not length count. Alright, so I think we're on to something here, and I'm just going to run it and see how it does. While I'm waiting for that, I'll try to get some debug going in case it fails. Okay, and it did fail. That's actually very annoying. It's very annoying, because I was really hoping to be done with this by now. Alright, so it's saying that test case is passed. Let's see what we can do. Okay, cool. So we passed this, and let's kind of just go over my solution. Let's clean it up a little bit, talk about what could have been done better here. So let's take a look at this. First, we initialize a count variable. That's entirely necessary. We also initialize a whole division, which I would argue is very necessary. Although you could technically throw all of this on one line and like not reuse it, because we're not going to reuse the whole divisions variable anywhere. So you could throw it on one line and use it to build whole count. But I just think that being able to separate these makes debugging easier. I think for development purposes, what we did was correct here. Partial length, this one's a little iffy, but obviously, I mean, again, it goes back to good development practices, and I think we're in the right here. Whole count does a good job. Partial count does not do so much of a good job. So what I would have liked to do is, you know what, let me ask ChatGPT about this, but we're kind of wasting a little bit of processing power because obviously, what does ChatGPT have to say about my code? Clean, and it works well. Repeat it, however, there's some areas. The logic for calculating the full repetitions in partial segment is sound. Rejects, occurrences is a valid approach. Fallback for no matches. Edge case handling, optimized performance. So, I also agreed with what it said about optimizing performance by reducing the regex patterns, and I think that's really so that's really the only place that this is lacking efficiency, is that we're both pattern matching for an entire string and for a partial, when in theory you could use a single for loop to iterate and grab the count at the partial amount and then grab the count at the whole and then multiply. Well, here we handle that, but yeah, overall not bad. The problems like this sometimes will lead you to think that you should concat multiple strings, but I want you guys to recognize that when you look at strings, or when you're working with strings, they're basically arrays of letters, and so whenever you're performing operations on strings, you're really performing operations on arrays, pretty much. And sometimes certain operations can be pretty costly, like resizing arrays is pretty costly. Adding elements that are, or like splicing a string can be pretty costly at some points. So overall, you want to try to avoid operating on strings, especially in this case where you really don't necessarily need to at all. All right, anyhow, I hope you guys enjoyed the video. I hope you guys learned something. Have a good day.